So here we will try to understand what is a conservative force, what are the properties of conservative force, what is a non-conservative force, and we also will do some problems related to this topic. So to understand conservative force, so let's say a particle is there at position A and we are applying some force, and because of this force it will move and it will reach to the point B, which is our final position, via path 1. So now let's say work done is denoted by WAB. 1 means work done from moving the particle from A to B via path 1. Now let's say for second chance it will move via path 2 and work done is denoted by WAB2. If both work are equal, then this force is called as conservative force. What does it mean? Particle can move from A to B via any path, and if the work done is equal, then it is called as conservative force. And the example is gravitational force. So what are the properties of conservative force? First thing we have already seen, work done is independent of the path taken. Whatever path you take, work done will remain same. It only depends on the initial position and final position. Second property is work done along any closed path is 0. Means let's say we are starting from A, we apply the force and it will come back to the same position. Okay, and total work done will be equal to 0. So that work done for this closed path is 0. Third is curl of conservative force is 0, means del cross F is equal to 0. Now to check whether force is a conservative or not, we can use any one property. So each property itself is a necessary and sufficient condition. So now what is a non-conservative force? For non-conservative force, total work done depends on the path. Means if we follow path 1, work done will be different from the along the path 2. Means WAB1 is not equal to WAB2. And what is the example? Frictional force. Now what we'll do is we'll do these two examples. We'll check these examples. So first one is, let's say one force is given 3x square y I cap plus 2x cube y plus cos z j cap minus y sin z k cap. And what we have to check? We have to check whether this force is a conservative force or not, or non-conservative force. So what we can do is simply we can find out del cross F. So how will you find out? What you have to take is we have to take the determinant of first vector is del, second vector is F. So we'll write I cap, j cap and k cap component. What is the I cap component for del? Dou by dou x. J cap component dou by dou y, k cap component dou by dou z. Similarly we can write the x component here, fx, fy and fz of the force. Now if you evaluate this one, now you can see this will give minus sin z and this will give plus sin z. So it is 0. Second part is also giving 0 and third part is giving 6x square y minus 6x square, again it is 0. So this means del cross F is equal to 0. So what we can conclude here is force is a conservative force. Now second example, what we'll do is we'll calculate the work done for two paths and we'll see whether it is equal or not. So let's say a particle is sitting at position A, this is our initial position, and which is 0, 0, this is the origin, and particle will move in two dimensions. One is x coordinate, another is y coordinate. Okay, and where we have to reach is we have to reach it to the point B, which is our final position. Now I can move along this path. So let's say this is path number 2, or I can go via this path A plus B plus C, which is path number 1. So I'll calculate the work done for path 2 as well as path 1, and then I will see whether it is equal or not. Okay, so now force is xy I cap plus y square j cap. What does it mean? Force depends on x and y coordinate, means at every point force will be different. So this means it is a variable force. Now the question is, how will you calculate the work done for variable force? So what we can do is we can take a very small displacement dr and we can calculate the work done for it. Let's say it is dw. Okay, and then we can integrate from A to B. So w will be A to B f dot dr. So what is f dot dr? Work done for the small displacement dr. Okay, and then you integrate for A to B. Okay, now the question is, how will you write your dr? So since it is two-dimensional problem, so let's say this is x coordinate, y coordinate, this is the position of the particle, let's say, and this is r. Now you can see r is in which direction? It is a mixture of x as well as y. So r has x and y, so we can write r is equal to x I cap, because this is I cap direction, and plus y j cap direction. Now if I apply some force and there is a very small displacement dr. Now how you write dr? Now you can see this dr is also part of mixture of x component, which is dx, and this is dy. So what is dr? Dr will be dx I cap plus dy j cap. So what is dr? Small change in r, which is equal to dx. What is dx? Small change in x. What is dy? Small change in y. Okay. Now what we can do is, first to do this problem we'll calculate f dot dr, which is xy dx plus y square dy. Now for what I will do is I will calculate the work done for path number 2. Now you can see path number 2, what is happening here, which coordinate is changing, we are moving along y, so y coordinate is changing from 0 to 1. What about x? X is constant, so what is the change? Dx. Dx will be 0. And what is the value of x for this path? X is 0. So dx will be 0, x is 0, and y is going from 0 to 1. So now if you put it here, what is f dot dr? Y square dy. Now how will you calculate the work done? You have to integrate from y is going from 0 to 1 f dot dr. So that will become y square dy, and that is equal to 1 by 3. Now comes to the path number 1. So first we will take this path A. Now what is happening in this path? Which coordinate is changing? X coordinate is changing, and x is going from 0 to 1. What is the value of y? Y is not changing and it has constant value 0. So y is equal to 0, dy is equal to 0. So dy is 0, y is equal to 0, x is going from 0 to 1. If you put f dot dr, here you can see dy is 0 and this y is also equal to 0. So what does f dot dr will become? 0. So this means work done for this path A is equal to 0. Okay, now comes to the path B. Path B, what is happening? Now which coordinate is changing? Y coordinate. From where to where? 0 to 1. What is the value of x? 1, and it is constant. So this dx is equal to 0. So dx is equal to 0, x is equal to 1, y is going from 0 to 1. So what is f dot dr? You can calculate y square dy. Now if you calculate the total work done for path B, this will come y is equal to 0 to 1, y square dy. This is equal to 1 by 3. Now comes to the path number C. So now what is happening? In this case, x is changing from where to where? 1 to 0. And what is happening to y? There is no change in y. What is the constant value of y? Y is equal to 1 and dy is equal to 0. So path number C, dy is equal to 0, y is equal to 1, x is going from 1 to 0. Now what is f dot dr? X dx. So w1c will be x is going from 1 to 0, x dx, that is equal to minus 1 by 2. So can you calculate the total work done? What is the total work done for path 1? A plus B work done plus work done for path C. So that will come 1 by 3 minus 1 by 2. So this is minus 1 by 6. So what does it mean? W1 is not equal to W2, means work done for path 1 is not equal to path 2. So what we can conclude here is this force is a non-conservative force.